Hello friends, today we are going to discuss about functions, definition of functions, domain and range of functions, and the vertical line system. To begin on, the first point is what is a function? A function f from a set of elements x to set of elements y is a rule, it's a rule. A function is just a rule. Which kind of rule is it? It is a rule that assigns to each element x in x exactly one element in y. This short and precise definition of function. See, to understand this point or this definition, we use diagrams. Look, this is a function f from x to y, and this one is a function g, which is g. Here, look at the two functions f and g first. On f, each element of x exactly assigned with each element of y only. Look, 1 assigned with 9, 3 assigned with 8, 5 assigned with 8, and 7 assigned with 7. But here, 2 is assigned with 3 and 2 at the same time. Are you looking? 2 assigned with 3 and 2 assigned with 2. This clashes with the definition. A function is just a rule that assigns each element of x with exactly each element of y. So under here, this one is not a function, but this exactly matches with the above definition. So this one is a function, but here is not a function because of the first term 2, which assigned with 3 and 2. The element of x assigned with 2 elements of y. Consider these first elements of x as a child, and second elements of y as a father. So here, any child will have only a father. A child willing able to have two fathers, two different fathers. A child only have one father. Here, 1, if 1 is a child, and the 9 can be his father. 3, his father will be 8. And 5, his father will be 8 again. But here, a father will have 2 or more children. When we consider the nature or reality, the analogy is here. If we consider the values of x as a child and y as a father, collection of fathers, so a father will have more than 2 children, but a child isn't able to have more than one father. So this is an analogy to understand functions. The other point is ordered pairs. In ordered pairs, it is easy to also distinguish a function from not from another relation which is not a function. For example, the above diagram can be changed to ordered pairs like here. The first is 1 is a relative is 9. Is a set of ordered pairs. The second 3 with 8, and 5 with 8, finally 7 with 7. This ordered pairs. Here the second 2 with 3, 2 with 2, 4 with 1, 6 with 1, 8 0. Here from the first order pair, any value of x is 1, 3, 5, 7. Those are different. We don't care about the term next to x. Here 2 2. Look, 2 2. but different y value for this the same values. As I told you, if you consider this first terms as a child and second terms as a father, this can't clash, this can't be function. It fails the definition because the first elements of x can't be assigned with the second elements of y exactly. The next point is vertical line test. Vertical line test simply is a way to distinguish a relation is with a function or not. The point is how to distinguish a relation, a graph of a relation, whether it is function or not. That's the point. It is simply checking whether a graph, whether the vertical line crosses the graph of a relation at one point or more than at one point. If the vertical line test crosses or touches the graph of a relation exactly at one point, then that relation or that graph of a relation shows us that as it is a function. But what if a vertical line test touches the graph of a relation more than one point or more than 2 points, like the second graph, then it will not be a function. This shows that this graph is not a function x which is equal to y squared, or y which is equal to under radical x is not a function, as the vertical line test crosses the graph at 2 points. We'll see how to draw graphs of a function easily in the coming lectures, but here y which is equal to x squared is the graph of y which is equal to x squared. The vertical line test only touches the graph at exactly one point here, so this is a function. The next point is domain and range of a function. Here, domain of a function. For a function fxy, the domain of f is the set x ordered pairs. The set x. Here, the other concept is domain and range of functions. Find our final concept. For a function f, which is from x to y, the domain of f, that the function is the set of x simply. You see, if there is a function which is made or combined from x to y, which is related from x to y, then the domain is just the values of x. For example, from if we look at ordered pairs as an example, for example, sets of 1, 2, for example, 3, 4, look, 5, 6. If this is some kind of ordered pairs of a function, then the domain is just the values of x. Our domain will be 1, 3, 5, and our range will be 2, 4, 6, simply for ordered pairs. But domain and the range of a function is much more complex. For sometimes if there is a function like this one and this one and so on. If the function cannot be expressed by ordered pairs, or if a function isn't given as ordered pairs, so how can we demonstrate domain and range of such functions? We'll see it together. The second is range of functions. As I told you above, range of function is in turn the values of y. If that function is formatted from x to y, then there are values of, or set of values of y is the range of function. It's not necessary to look at your ordered pairs as an example, because we saw it above here. Here we saw it. The range here is set of y values, that is 2, 4, 6 will be the range of the function. The other concept is examples. Examples on domain and range of functions. Here y which is equals to x plus 4. So how can we demonstrate the domain of this function and the range of this function and the graph of this function? Look, y which is equals to root of x plus 4 to be valid. this function, what will be the x values? This is the domain, short and precisely. To make this function valid, what will be the set of x values? This is the domain. So here, for the function y, which is equals to radical x plus 4, be valid, in general, out of the radical, there are going to be negative values. So x plus 4 must be greater than or equal to 0. You see? We can't get negative values out of radical. So our first assumption is x plus 4 must be greater than or equal to 0. So our x is implies that our x must be greater than or equal to negative 4. This is our domain. You see? In order to this function valid, x must be greater than or equal to negative 4. What will be the range? Shortly, we can't get negative values out of the radical. So our range will be any value which is greater than or equal to 0. The minimum value of y will be 0. As I told you, the range is a set of values of y. So the minimum value of y is 0. This is when x is negative 4. Then our result will be 0. But we won't be able to get under 0. So y will be y greater than or equal to 0 is our range. So domain is such that x greater than or equal to negative 4. Our range is y such that y greater than or equal to 0. This is the domain and range for the first function. How to demonstrate the graph of y which is equal to x plus 4 under this domain? We can consider from the domain and ranges. Look, if this is xy coordinate and our domain is x greater than or equal to negative 4, x greater than negative 4. We can draw the graph beginning from here to the right side. We can't go behind this because our domain limits us. Our range is y greater than or equal to 0. Our graph must be above here. It mustn't be under here because our range limits us. So now let's find x and y intercepts from the function y which is equals to radical x plus 4. When x is 0, y will be positive 2 and negative 2. When y is 0, x is negative 4. X is negative. So the graph will look like this one, and the under part, the graph will look like this one, and here it look like this. But we can't draw the under part or this the second way because our range limits us. The range is y greater than or equal to 0. If we draw this graph, y will be less than 0 between negative 2 and 0. So our graph is just only here. So from the vertical line test, we can check this graph whether it is a function or not. If we draw any vertical line here, it touches the graph exactly 1 point. So it's a function. This is our first example.